Good morning, everyone. Hope you're ready. Hope everything is good. So it's now 8 a.m. exactly. We still have some a small number of latecomers. So what we will do is I want you to start getting ready for the session. Are you seeing a whiteboard on your screen right now? Perfect. So I am just going to paste some text. There we go. So we're just going to take 5 more minutes just for the rest of the students to join. And in the meantime, please do the following so that you can like not waste their time and really win something. So I want you to first go to this website. I will give you the link. So it's the website test and just try it out. Make sure that everything is in green and you have everything ready. So there's no problem with that. I will give you the link in the notes section. So you should see a notes section on top right. I will put it right there and done. And I will also put it in the room chat there. So please go and check that everything is good there. And then for the rest of the 5 minutes, make sure that you have an Nvidia account created already. So the link is coursenvidia.com/join. And then navigate to this link and put the event code there. So everything is also in the notes. If you check the notes part on top, you can find the same instructions, the links. Please just go there. If you don't have an account, make an account. If you don't have yet access to the course, please just set the event code. And please make sure when you copy and paste the code, to not leave any spaces. So sometimes you may copy the code and you end up, for example, taking a space at the start or a space in the end. Make sure that does not happen. Once that's done, you should get redirected to a course page. If not, here's a link. Also, you will find it in the notes. I will put it right now in the notes. There, in the notes. And then on that page, click on Start Course on the top right corner. It should be somewhere right here in that page. And then click on Launch Course and just wait for us. Yeah, so please just do this for now. 3 more minutes, 4 minutes, and we will officially start. If there's any problem, please just tell us in the room chat. We will be here. The team is here. We'll just take 5 minutes and then we introduce ourselves and start officially. So yeah, good luck. Okay, now we're good. We should be good now. So we can officially start the session. First, mic check. Can you all hear me? Please tell me if you do. Perfect. So there's no problem with my microphone. There we go. Just going to put this here to see everyone. And there we go. All right, then if that's the case, let's hit it off. So, welcome everyone. Welcome to the Fundamentals of Deep Learning workshop. I'm Elias Manai, and I will be your instructor for today. Together with a team of TAs, teaching instructors, we will try to help you in this workshop for today. For the next 8 hours, we'll be here for you to help you out. Uh, Again, so before we begin the course and before we introduce ourselves, I'd just like to go over a few unique items unique to this like online delivery formats. If it's the first time that you are on a workshop, uh, just so that everything is good. So as you enter the classroom, you may have noticed that your microphone and webcam are off by default. There is nothing wrong with that. It's intentional to avoid background noise. So by default, normally everyone will have their everything that will have their mics and their webcams off, and some people can hear that part there, just to avoid that. So I will make sure, and the teams will make sure that everyone will be off. So your main method of communication will be via chat. So it's gonna be via text. So as you can see, normally you have two chat channels. There is one on the like if you look at the right side of the menu, you have the room chat, and then you have two types. So there's on the left what's called a room chat, which is the one that you are talking right now on, and that's visible for everyone. So everyone, each and every one of you can text there, can ask questions there, can give some feedback, some problems, whatever it is, and it will be visible for everyone. And then the one on the right with the question mark, it's a private chat channel between you and us, the TAs and the instructor. So in that channel, if you type a question or whatever it is, well, not everyone will see it, only we can see it, and that allows us to like deal with some problems that are, for example, unique to you, some errors, some issues, or some kind of private question you want to ask. Now, just as a heads up from now, when we get a question on the moderator chat, sorry, on the Q&A chat, we can choose as TAs to either reply to you or reply all, meaning that if we find that your question is interesting enough and important that many others should hear it, we may choose to reply all, and that's why you might sometimes see your question visible for others. But if it's a private question, if it's an issue or something else, be assured we will keep that between us. So that's for the chat. So the main focus will be on text. Then, in general, simple answers will be answered so immediately in the room chat, and some questions might be, let's say, deferred until a Q&A period starts. So if the question is relevant to the material for example, I'm explaining right now, or on the hands-on part, then yes, I might stop and take time to explain better or re-explain. But if we find that the question should be, for example, will be answered later or will be better off deferred in the QA part, then we might take the time to not answer and then go back. So if you ask a question and I did not stop, for example, and answer that, or someone has left it open, don't worry, we'll go back to that. Uh, so afterwards, if you have any complex issue, so if for example, you have an issue with the platform, you have an issue with the course, there's some kind of things that might need a lot of explaining, etc., etc., it is possible to get you into a private room with one of the TAs, and there you can discuss with the TA directly your problem and take your time. This is called a breakout room, and we will try to see it. Hopefully, we don't need to use that. But in that case, in the case where you are facing a problem and none of the answers are helping, then you can request for a TA to join you on a breakout room, and we will try and help you there. However, just one small detail is uh, if you come back, well, if you go to a breakout room and then you come back, By default, it's the platform thing. By default, your webcam and your microphone will be on by default. So just as an information, when you come back from breakout room, please make sure that you remute your webcam and remute your mic. Otherwise, I will just have to click on the mute all. So yeah, just as a heads up. If that's what happens, I did that. No problem if you can't find the launch button. We will do a walkthrough of the platform. So just stay with me and take notes. So yeah, please try to take notes right now because some questions you're going to ask later. Let's get it out of the way. Okay, so afterwards, I see that some people already found the raise hand button. Most likely, we will not need that because you have the chat, you have the private chat. You can just ask there, and we will be using polls. So polls will allow you to like answer questions. For example, I will use that to ask you where you are, what part of the project are you, and you will be using that for analysis. For the rest, you can just use the chat. All right. Um, then for the internet, yeah, some people might have problems with the browsers. So Chrome and Firefox are the supported browsers. Edge does work, yes, uh, but usually we have less problems when we use Chrome and Firefox. So if there's any problem, you can switch between these browsers, see what works for you. Some users, especially on Mac, may need to allow pop-ups for the neuro.com website. So if you find something, you should check the settings on top on the bar. Maybe there's a prompt for a pop-up that you should allow access to. Yes, you can use it in Explorer as long as it works. You're good. The best one would be Chrome and Firefox, but sometimes you get some problems on that. So just go with whatever works for you. Finally, if you have a VPN, sometimes some problems can be like offed by just removing the VPN. Okay. One last thing to say is that depending on your internet and the bandwidth, sometimes you may experience some delay. Let's say 3 to 5 second delay between what I'm saying and what's on the like on the board, like what's on the slides, for example, and that's normal. Uh, if you have any kind of like delays, if you have any kind of sound problem, for example, suddenly you can't hear me anymore, suddenly you don't see the slides moving anymore, whatever kind of problem, in most cases, you can solve that by just refreshing your browser. So you can do the normal refresh, or I would suggest doing the force reload. So it's either Shift Control F5, or I don't know how it is for Mac, but you can just even do a right click on the tab on the top and say force reload. That usually solves 80% of the problems. All right. So this is it for the prompt. We will be having an estimate of 8 hours together. We already used up 60 minutes of that, but usually we do finish before those 8 hours. So there's plenty of time for you to practice and test, and there's plenty of time for us to work together on this. The good thing is that uh, like you do not need to finish everything today for the session. You have up to 6 months after this, after today, to work on this and finish the assessment and submit your work and get the certificate. So today is just the first day. Starting from today, you have access for 6 months to finish the course. So no problem. Even if today you did not manage to finish it, there is no problem. You can do it at home anytime. However, there will not be a recording, sadly. So you need to focus a lot and try to be with us. So if you have something to do afterwards, you have to go and you can't come back. I'm sorry. You do have access to the presentations. So the slides I will be presenting, you have access to them on the platform once you start the course. Uh, you can download them, but you cannot distribute them. So that's the thing. You have the right to download for your own use case, but you do not have the right to distribute it. And if you get like caught, well, you may face some issues, some problems. Like I don't know. I don't want to say anything since I'm not ideally a person, but you may face some issues. So please do not distribute. You can keep the code, you can keep the slides, but do not give it to anyone else. and there will be no recording. So that's it. All right, let me check. Is everything clear? All right, perfect. And another question would be, am I speaking too fast? Amazing. One last question. Am I like loud enough? Are you hearing me loud enough, clear enough? Amazing. Then we are good. In that case, we can get right into it. Um, So before we start everything, let's just take the some time to introduce ourselves formally now. The team that will be with you for the next 7.5 hours, starting with myself. So my name is Elias Maniai from Tunisia. I'm a machine learning consultant specializing in robustness and education. So I've been doing this for 3 to 4 years now. I mostly mentor startups and help them like integrate AI into their business. I'm also a Google developer expert in machine learning and a mentor at the Google Startup Accelerator. And I've been with the DLI and Nvidia DLI for like some months now. This is my fifth session, and it's actually my first one as an instructor. So, yeah, glad. I'm glad I can try that. So, there might be some problems with that. Cool. So that's for me. Who wants to go first from the TAs and present themselves?
Hello, Alice. I can go.
Hello, Jack.
Okay. My name is Jack, and I'm actually from Nairobi, Kenya. I'm a machine learning instructor at Africa Data School, and I'm also a certified instructor for the Nvidia DLI in a couple of courses. And besides, I'm also the Raza developer for Huri AI, and I'm actually glad to be here to participate in this insightful workshop today. Thank you.
Thank you, Jack. Oh, really happy to have you with us. So, who wants to go next?
All right, hello guys. Can you hear me?
Yes.
All right, my name is Dinizim. I'm still a student. I'm computer science student, and I've been working like as a deep learning instructor with Nvidia for a couple of months, and this is actually my first session. So really excited to be with you, and good luck.
Hello, do you hear me?
Yes, we do, Mohammed.
Yeah, I'm Mohammed from Algeria, lecturer at university and a researcher in artificial intelligence. I'm NVIDIA ambassador. My research is about machine learning in agriculture application. It's all about me. I'm glad to be with you here to support learners.
Amazing. Happy to have you with us, Mohammed.
Thanks.
Can you hear me?
Yes, we can, Ahmed.
Okay, so I'm Ahmed Awadi, machine learning engineer. I am part of the operations team at Information Technology Institute, and I teach machine learning and deep learning course in Egypt.
Glad to have you with us, Ahmed.
Thank you.
Abdel Ghani, do you want to introduce yourself?
Hi, hi, good morning. You hear me?
Yes.
Yes, I am Adlani Kabout from Algeria, machine learning research engineer. I think that we will enjoy today the training. So just we should have fun. Thanks, Elias.
Thank you. And as Abdani has said, and the most important part of this is to really have fun. So we said this like the 7 hours that we're going to spend together. We're going to try to keep it interactive as to not bore anyone, and we'll try to give you insight. Not only like give you like not only explain the things that are on the course, not only talk about technical stuff, but also try to give you more insight in the real life applications of deep learning. So as you see, everyone here is experienced with a mix of industry and research. So hopefully we will be able to give you a lot of added value. All right. So that being said, let me give you a simple timeline. So we have 7.5 hours to go. Most likely, we will have a small 15 minutes pause at, let's say, in 1.5 hours. And then we go on for 2 hours. We have a lunch break for 1 hour, and then we're gonna go again 2 hours, and then we're gonna have another 15 minutes pause at, let's say, 2:35 p.m. CET plus one. So I don't know. I think each one of us is in some kind of time zone. But basically, we're gonna have blocks of 2 hours, 15 minutes, 2 hours, lunch hour, break, and then 2 hours, and then another 15 minutes, and then we're gonna finish the rest. So that in that way we can continue to breathe and focus and not get deterred. All right. Now, going back again to this. So, has everyone managed to get access to this? Has everyone managed to access the platform? Yeah, sorry, probably a small problem. Okay, perfect. So some of you already have access to it. Some of you still are still like trying to have to fight it. So no problem. Let's go with that. Uh, I'm going to disable this now. Let's disable the whiteboard. That my mic and webcam is turning off. I might have some small issues with internet for now, but I hope it will be fixed in a bit. Okay, so let me go back to tools, and I'm going to share my screen for you now to see what you should be able to see. So I'm gonna start my screen share, and then we're gonna go to this class. Okay, now you should be able to see my screen right now. And if we follow the links that I have put, the first part would be to go to nvidia.com and share and join. So I'm gonna post the link. Okay, somehow my desktop share has broken. Start screen share again, window, and then sign in. There we go. Okay. I don't know if this is a problem from the product or what. Yeah, there we go. Okay, so when I go to courses.nvidia.com/join, you should get this. And in this case, you should have an account already created. So in this case, just like sign in with the email that you use, sign in with the account you have, and it should now get you to not this one. It should be in the to this. Yeah. So this is your dashboard. So your course activity. In this case, this is now your account. And so in your case, I think maybe you don't have any of these yet. It's because it's your first time you create one. So we will give you access to your first course. We will go and paste this time the other link, which is the /DLI event. So the join was just for you to create an account. And now we have this. You enter the event code. This is a part where you go and copy the event code from the notes or the chat. Come back here, paste it, and make sure there are no spaces after and before. Make sure there's no spaces. See there's space? Yeah, there we go. So once you do enroll, well, in my case, it's already enrolled, but hey, let's try it. It should get you to this page. So the one with the course. There you can click on Start Course on the top right. And then you'll have this like launch. So in my case, I have already launched it, so that's why I have three buttons. In your case, you should just have two buttons or one button, I think. Yeah, just one button with a launch. So you should then click on launch to for it to start like launching the course, and it will take about 3 minutes, 3 to 5 minutes, and it will then give you access to the slides and give you access to a Jupyter lab. So let me check. Uh, is there anyone who has problems with this part? So if you are okay, just type okay. If not, please tell me that you have tell me at what part are you stuck. Perfect. So I see a lot of people already are okay. Amazing. Amazing. Perfect. So now that you have this course, so what's happening actually is that we have access for 9 hours. So I don't know if you can see this, uh, but you have access to now 9 hours of access to the Jupyter Lab. And as some of you are already saying, it gives you access to some kind of Jupyter Lab, which looks like this. So this is a cloud compute container that is given to us, and you can use this for free for now 9 hours. Okay. After the 9 hours, it will automatically stop and free the resource for other people to use. In those 9 hours, we have access to the slides that we will use now for everything, for like for the training. You can revisit them for anything that's in theory. And in here, so if you used Jupyter Lab before, if you used Google Colab before, this will be familiar to you. This is where we'll be doing all the practical stuff. So you will have access to some code. You will have access to the cells, and we will be writing all of our code in the cells, executing them, and going on and moving forward. So each one of these notebooks has a task and has some problems you have to solve. And once we finish all of these, which should be by the end of the 8 hours today, then we can go back and click on Assess Task. Once we do that, and you do not do that unless you finish all of it, because once you click on that, it will go to assessment.ipnb and it will evaluate the code that's there. So if you don't have any code written there, please do not assess the task because it will give you a bad score or a zero if it's so empty. Okay, so just making sure I see, is there any issues? So you're able to see Jupyter Lab? Yes. Timer, no problem. Don't. The timer doesn't matter. How can we access Jupyter Notebook? So if the notebook does not open by itself, just go and click on Launch. Every time you click on Launch, it will open this part up. So you can also like close this and launch it again. If there's any other type of problem, you can like stop the task and launch it again. But for now, since it takes a lot of time, if it's launched, just keep it there. Don't touch it. Okay. Let me check. Cool. So it seems like everyone is here. All right. Then that being said, I say this again. You can access the slides. You can maximize the slides. You can do all of that. You can download the slides, etc. You know this. The code also, as I said, you are able to download the code from here. It's a Linux cloud, like a Linux server. So you can use anything from Linux to download or just do it manually. There's no problem with that. And finally, that being said, I think there's nothing more I can tell you. We can just start right with the course. So for today, the course will be fundamentals of deep learning. So the basics of what deep learning is, which in this case will mean that we will be exploring what's called neural networks. We'll be exploring all of the intricate concepts behind machine learning and specifically deep learning. If you ever heard of training, of inference, of testing, evaluation, if you talk about layers, we're going to talk about image classification, convolutional networks. There's going to be a lot to dive in. And usually you might see there's 6 slides, and in the Jupyter Lab, there's like 7 assessments or something. The first 3 will be the most heavy ones. The first 3 will be the most technical ones, and they will take the most time because they're the first ones with a lot of concepts. But then 4, 5, and 6 will be some small additions. So don't worry, we'll be on time. These 3 should take us 3 hours or 4 hours, but then these ones will be done fast. Okay? What's happened? When the timer runs out, it simply stops the task, and then you just have to launch it again. That's it. Is the notebook available after the 9 hours? No. After 9 hours, it will stop it. You have to launch it again, and then you will have to start from scratch. So that's the thing. Okay. So, any last questions, or can we start? If you have any question, please tell me. If you want me to start, just type start. Perfect. Yeah, how to mute the chat notification. So you must have allowed the smart row or this application to give you notifications when you started. So yeah, just go to the settings and change that. Change the part of notifications. So change that, like disallow them to give you notifications. And yes, the progress will be deleted after 9 hours if you're not able to finish in time. But hey, no problem. Okay. Let's go right into it. Our first slide of the day, our first presentation of the day, will be about the actual history of AI and how we came to deep learning. So again, since it's fundamentals of deep learning, I'm assuming that you do not have a lot of knowledge about this. I'm assuming that it's the first time that you meet this, and I'm assuming that you don't have any experience with it. So I'm going to start with an introduction to deep learning, and then we're going to build our way up. Just to make sure, is that right? Can you please tell me what level of familiarity you have with deep learning? Is it like the first time? Do you have zero, none? Oh, perfect. Start none, 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 zero, none, none, none. Perfect. You are exactly the target audience. So without any further ado, let's just get right into it. So, introduction to deep learning. Let's understand together what it is and how it starts and how we can work with that and understand it. Okay, so let's start it. The goal of this course is, as we said, to get you up and on your feet quickly, meaning that while we want to build a foundation to tackle deep learning project, we will do that like starting right away. Like the first section, the first part, you will be attacking a project. You will not be able to understand it maybe at first, but you will get you up and running. So we will not cover the whole field, but we will get you a head start. And this head start will allow you to then work on your own project. So you have the code, you have the mindset, you can start from there. And it's to give you the foundation with which you can read articles, follow tutorials, take some YouTube videos, etc. Just let me mute there. Oh, hello, Konstantinos. Okay, so we have 6 parts in this in our agenda. The first one is this, the introduction to deep learning. So it's more of a historical part. Let's talk a high level. Then we're gonna do the first task and the hands-on exercise. Then you're gonna go to how a neural network trains and see how the math behind it and see the theory behind it, etc. We're gonna then work on another hands-on exercise. We're gonna then tackle image classification and talk about convolutional neural networks, again, with an exercise. Then we're gonna see how we can get better results, more robust results using what's called data augmentation, and then how we can deploy it, meaning how we can use it now if we have an application, a web app or whatever, again, with exercises. Finally, we're gonna talk about pre-trained models, meaning that with all the technology we have now, we don't need to collect a data set and do everything yourself. You might have things that are already ready and you can use them. You can use them like from without any effort from your side, which is the pre-trained models. And in the end, we'll be talking about more advanced architectures because all of this is tackling the simple neural networks, deep neural networks, convolutionals. But in this case, we talk about other type of architectures, like for example, RNNs, which are used for text, reinforcement learning, GANs for generating. And this is just to give you an insight of what's out there and allow you to like get interest and motivate to follow other workshops. All right. So for the first one, which is the introduction, we're basically going to go with the history of AI up to the deep learning evolution, then explain what it is, why it's so good, and then overview of the course. And we're going to start with the first exercise. Remember, we're here to have fun. You will still be able to access the contents. So just have fun, ask questions, give recommendations, and you will hopefully get a certificate, that's for sure. All right, let's get started. So history of AI. You have to understand that when we talk about AI, machine learning, and deep learning, there's different phases. So the term AI, artificial intelligence, is actually something that's been around pretty much since the start of computers. But now, because we still say AI, we think it's something new. So actually, when you talk about AI, we are talking about the computers, what we like programs, software programs that are made in part to complete human tasks. So these ones were created in the 1950s with the first computers. And at the time, there was no concept of a computer being able to do something. It was all manually done by humans. So if there was some type of system that can do something like, for example, math, instead of a human brain doing it, at that time, that was something unheard of. And it was called of like that's where it called like artificial intelligence. It's not natural intelligence. And when it was made, it was, as I said, used for simple things like math, arithmetics, and cryptography. And at that time, people thought that they could manage to build like sci-fi level of AIs like the one that you see in films very quick. So at that time, everything looked like possible. It was hyped up, and they started working a lot on AI. So there was a lot of progress from 1950 up to 1970 and 80. But then, as they started to tackle more and more complex problems, they found out that it's actually harder than expected to deal with those problems. So AI at the time was some simple algorithms, math-based, yes, but still simple, and they were not able to like solve very complex problems. So it turns out to be harder than expected, and that's what caused what you call the AI winter, meaning there was no progress, not no progress, but no significant progress for like 20 years or so until the creation of deep neural networks. So that's where we started. 1950s is AI. Machine learning is like the late 90s, first 2000s, and deep learning is the rest up until now. So, as I said, neural networks, so deep neural networks were what changed things. But normal neural networks were created also in the 50s, like in the first decade. And they are inspired by biology. Basically, these are some attempts by scientists to mimic the human brain and see, like, try to make a computer version, a replica of the human brain with neurons and like information passing from a neuron to another. And they tried to create that. It was good, but it was really like rapidly outclassed by other programs, normal programs who can do much better. That's we're gonna see why the limitations happened actually. And those programs, which are the simple programs that we know, are what we then called expert systems. And it's just a fancy name, actually, to just say a very big computer program. So you'd have a team of 100 engineers come together and create a platform, create an application, create some kind of software with like thousands of hundreds of thousands of lines of code, etc., with a lot of rules, and it would be highly complex, and it would be a lot of modules, and there would be a lot of rules. So they would get, for example, if they work on, let's say, biology, they would get a lot of biologists, and they would ask them how do they do their work, and then they translate that into code, and they do that also for finance, for military, for defense, for cybersecurity, whatever it is. So expert system is just a fancy way of saying a very big software with a lot of rules made by humans. And for all intents and purposes, it did just that. It did right well, it did very well, and it's still used up to today, even in banking systems, even in like security systems, it's still good. But there are always some limitations. In that case, since expert systems are like rules in the end, which are coded by humans, well, the thing is that sometimes the problem is a bit tricky to translate into rules. For example, if I give you these three images and ask you what are these three images, you as a human will find it easy to just say the first one is a wave, the second one is a cat, and the third one is part of a car, because we as humans we find easy to detect objects. But if you want to make a program that does that, then you will find it is very, very, very difficult to actually do that, because what makes a wave? What makes the cat a cat? So there's a lot of issues. You might say, okay, it's the pointy ears for me, but dogs also have pointy ears. It's the face shape, it's the shape of the face. Okay, but how do you quantify a shape of the face? How do you know that this is like the front part of a car? How do you know this is like not a bottle of water or something else? So when we go into these kind of problems, which are usually uh, like object detection or let's say pattern matching, then expert systems have limitations because sometimes we do not, like we cannot really translate into code what you are trying to see. And even if we do, there will always be some kind of new pictures, some kind of new problems that are fundamentally different from what you saw. And you will have to also encode that. So it becomes time consuming, too much of a resource to use, too costly, too many engineers for a low return. So this is where there will have been limitations. However, we humans, we find it easy to deal with this kind of problem. For example, children, and well, us too, but when we were all children, we learned about the world by just getting exposed to it. So we would go around, touch things, we would bite things, eat things, and then we would say, "Hey, this is a cat," and our parents would say, "Yes, that's a cat," or "No, that's not a cat." Fire is bad, fire is not good, whatever. And then we get exposed to that for years and years and years until we have a kind of a pattern, until we learn some kind of pattern. And now it's easy to say, "Hey, this is a computer. Hey, this is a person," etc. But when you want to make a program that does the same thing, you find it difficult. You cannot translate because you are so used to doing that with finding the patterns that you find it very difficult how to write it. So this is where actually machine learning and deep learning and AI in general really shines, because these are types of algorithms, they are types of programs that do not rely on rules that you have to find out if you do not know how. They literally just take some data, they take some examples. For example, you tell them, hey, this is a picture of a wave, this is a picture of a cat, this is a picture of a car. Now do your thing and learn how to differentiate between them. And it does, it manages to do, because it is not based on rules, it's based on math. And when it is based on math, then in that case, it does not matter what the rules are. It can mathematically find a way to correctly guess and then give you the result. So basically, we went from knowing what happened exactly but getting limited to getting a lot of good results, but you don't really know why. And that's the main difference actually between them. So that's the main difference actually between the machine learning, deep learning, and like traditional expert systems and traditional AI, which is just like some rules. And this has been even like let's have been like even more and more explored and more revolutionary with the appearance of deep learning, because what I was trying to tell you, what I was presenting, could also be said for machine learning. So machine learning and deep learning are essentially the same. They are based on the same things, the same concepts, but ultimately the difference is the algorithm used. In machine learning, you have many algorithms. In deep learning, it's based on one big algorithm called neural networks, deep neural networks to be more precise. And we could not really explore the power of that because of some limitations in that time. Remember, I'm talking in the 1990, like the late 19s. We are talking start of 2000s, and that time there were a lot of problems. So the deep learning revolution came when those problems got actually solved. And it got solved how? First, by the emergence of a lot of data, because if you want to train models, let's say machine learning models, so we don't say machine learning algorithms, we say machine learning and deep learning models because they try to model the data. It's like a mathematical model. However, in programming, we say a computer program. So it's a program with instructions and rules. But in deep learning and machine learning, we say it's a model because trying to model the data mathematically. So, anyways, uh, neural networks and deep learning and machine learning, so let's just focus on deep learning for now. They need a lot of data, a lot of information, a lot of pictures, a lot of examples to understand, to start to understand, hey, this is that, etc. It's not as easy as we humans. You can see it one time and bam, there we go, you have a start of a like a solution. And at that time, there was not a lot of data to go around. So with the emergence of the internet and the digital era, that data has been supplied, and now we have way more data than we need. So that's one part that we have solved. The second would be the computing power, because even if you have a lot of data, well, it's in the end a computer program that's trying to learn. So it's a lot of computational processes. There's a lot of math behind it. So we have to do a lot of computing. And at that time, well, we weren't having like some super powerful computers. We had like 256 megabytes of RAM or something. So it wasn't possible even if you had a lot of data. I'm sure you've seen all the pictures of like how hard disks used to be. Like they were as big as a human, and they could only hold like 1 gigabyte something. So you could not do anything like performant with that. But now, with the emergence of let the emergence, let's say with the progress of all the computing power, a small laptop now is way more powerful than a whole lab in the 90s. And so we are now able to compute, and we are now able to use deep learning and use like do compute very large amounts of data in relatively small time. And so that has allowed companies to be like profitable, allows the researchers to work on some better projects, and even us students and passionates to just work for fun on that. And the main power horse of the computation power would be the GPU, which is the graphical processing unit. So the GPUs, as you may know already, are mainly used for graphics, for video games, and let's let's we can say for cryptocurrency, etc. But mainly they were used for graphics. So the main purpose was to for graphical use cases. So an example of a graphical use case would be to render an image. So as you can see on the left, we have a rendered image right here. Why the GPU has been successful at this instead of the CPU? Well, the CPU, the central processing unit, is very fast but cannot handle a lot of things at the same time. It's not powerful at doing simultaneous things. It's not good for parallel things. However, the GPU is good at that. It's not as fast as the CPU for each one of the cores, but having like hundreds of cores at the same time, or even more than that, it manages to get things done much faster. So a good analogy would be to think of a CPU like, let's say you have CPU with 4 cores or 8 cores. It's like you have a motorbike. So a motorbike is very fast, but can only hold 1 to 2 people at the same time. So 4 or 8 of them will only hit 16 people at most, but they will be very fast. However, a GPU would be like a bus. So the bus is not as fast as a motorbike. It's still relatively fast, and it can hold like 25, 50 people at the same time. So if you have a work, a task that can be parallelized and do and like have it done at the same time, like rendering an image, you would get like a patch of pixels. Let's say you start with this, and then another patch, another patch, another patch. Since all these are pixels, you can do parallelization with GPUs, and then you can get the result in a record time. And the same thing for neural networks. You see all of these circles, for now, let's just call them circles, is a mathematical function, and will have some process and math behind it. So with a GPU, we can also parallelize this and do the training in record time. So that's why the GPU is way more important now, and that's why there's a lot of work on that. So now there's also TPUs, which are specific for machine learning. We have like giant GPUs that we can use now for SAMP. We have Google Colab for free. We have the compute power, etc. So yeah, the GPU has been the biggest like power horse of the computing power, and with the data from the internet, we have everything for the deep learning revolution to happen. But then, what is it? Like, what is the deep learning revolution? Or what is deep learning in itself? Just checking that there's anything. Yeah. Okay. Sound does not work for me. Yeah, just please tell him to refresh the browser. And we have like a question for the TPU thing that's interesting. If anyone can give a link to TPU and say reply all, that would be perfect. So TPUs are, you can see that it's something hardware. We'll not talk about that in this one, but yeah, one of these hopefully will get you a link to for everyone. It's something interesting you can see. So what is deep learning? As I said, deep learning is very fundamentally different from traditional programming. And in this case, it flips traditional programming on its head, like they say. And that's because in traditional programming, when we, for example, say we want to build a classifier, traditionally what we do is, okay, we get a team of software engineers and say, hey, what's the classifier for? Okay, it's, for example, an animal classifier or let's say a farm classifier. It's a crop disease identification, whatever. We get a team of engineers. We get experts from the subject matter experts, so people who know their stuff. And we define a set of rules for classification. So they tell you, the experts will tell you how they do the classification as humans, and the engineers will program those rules into a computer. And then what it does, it will get some example data, and for each example, for each input, they will test the program and see if it yields good results or not. If yes, we're good. If not, then we go back with the expert, we add another rule or a set of rules, we program those again, and then we test them again. So it's a continuous loop of testing, 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 where each time we find a problem, humans have to go back and find ways to combat that and test it again, etc. So in this case, the data is just a reference, and the humans are the main powerhouse behind the classifier. There's also another problem that I just give the profession afterwards. However, if you use machine learning to do that, it's fundamentally different. In this case, the data is not a reference. The data will be itself the rules. So in this case, a machine learning model, again, I say model, not program, because it's math. So it's based on mathematical functions. You give the model some examples with the answer. So for example, you would give him like 1,000 picture of a cat, 1,000 picture of a dog, or let's say something more interesting, 1,000 picture of a 1,000 picture of a type of insect that can harm your crops, and 1,000 picture of insects that do not harm your crops. And you tell them, hey, these thousands, they are harmful. These thousands, they are not harmful. We do not tell anything else. We just give them the data, give them all the data, and tell them, hey, these are harmful, these are not harmful. The model will start randomly taking guesses at first because it's based on math. So you're going to give it like some random variables to start with, some random coefficients to start with. Imagine this as being a long function, so y equals mx plus b, etc. And from there, it will take guesses and say, hey, this first input, I think it's harmful. This second input, I think it's not harmful. And we tell each time if it's right or not. So if the first one is correct, we say, good job, that's correct. However, if the guess is not correct, we say, hey, that's not correct, there's an error. And you do this for all of the inputs. So if you have 2,000 inputs, 2,000 images, let's say the model got 500 of them right, that means that you have 1,500 errors, which is a lot of errors. We do not want errors. Ideally, we should have 0 errors, but we'll talk about that. So when we know how many errors we have, the model then learns to correctly categorize the inputs by changing the coefficients inside. So it's a math function, so we have coefficients. So what we do is we calculate the error, say, hey, you have 1,500 errors out of 2,000, you want that to be 0. So it goes back, it changes the internal coefficients in a way that allows it to minimize the error. So the algorithm behind it we will explain in the second part. And basically what's doing is it's just finding a combination of weights and coefficients where it correctly guesses the inputs with the outputs. So in reality, the model will be excellent at doing the task. It will be excellent at classifying harmful insects from non-harmful insects. It will be able uh, to to help farmers within this case, so we can ship that model to a actual, like for example, Raspberry Pi or something kind of a deployment, and it will manage to give you good results, and the farmer will be happy, and you will be happy. However, when we ask why, why like this one is harmful or why not, we have no idea. So it does not know why, but it's just good at it. So that's how it works. The system learns the rules on its own. It will be better than humans at doing the task, but it will have no idea how it was done. However, in the past, in the traditional, we would have less of a good classifier, but we would know exactly why it was said yes or harmful or not harmful. So that is the trade-off. If the problem is simple, so there was, if the problem is simple, the rules are clear, they are straightforward, you understand it, there's not a lot of, let's say, random stuff going on, then you can just go with classical programming. No need for fancy stuff like deep learning. However, if the problem is complex, you don't know how to translate the rules into code, you don't know when to start, etc., then yes, by all means, you can use deep learning in that case. It also can depend on the kind of like the can also depend on the industry. For example, some industries you cannot go with deep learning, let's say financial industry, medical industry, because you need to explain why you you took a decision, why you said yes or no to this kind of thing. In that case, you cannot really use deep learning because you can't just say, hey, the model said this. We need an actual like explanation. So in those kind of industries, the people there are kind of forced to use machine learning or classical programming instead of deep learning because they allow that, and they would trade. In that case, they would trade accuracy and precision for explainability. But that's another problem. For now, we don't care about that. We are just here to learn how to use deep learning. So let's go right into it. Uh, so when you compare deep learning to other AIs, the thing is, when we say other AI, we mean both expert systems and, in this case, specifically machine learning. So as I said, there's machine learning and deep learning. Both of them are based on the same thing I've been like telling you now, but deep learning uses something called deep neural networks, and just by doing that, there's a fundamental difference between it and machine learning. So in deep learning, we have depth and complexity. We have very deep and very complex networks, meaning that we're going to handle like very long, very big kind of models with a lot of parameters. We're talking millions and billions of parameters, and the best ones out there are now in the trillion of parameters. So you can imagine if you have trillions of coefficients to tweak with like gigabytes of data, it's going to take a lot to train that. We also have many layers in the model. So the key difference between like neural networks, which is called machine learning, and deep neural networks, which is called deep learning, is basically the number of layers in the model. We will see some pictures in a second, but normal neural networks or machine learning basically are just like one input layer and one output layer. But deep networks will have one input layer, one output layer, and several hidden layers which will do all the math. So that's the key difference. It just simply means this it's more than two layers. That's basically it. And that key difference, which is not one but many layers, is what allows deep learning to be able to learn complex rules and be able to do all of the advanced stuff that we are seeing now. So as much as it's like a small difference, it created a different universe, and you're gonna see how it works under the hood in a minute. So how it managed to do that? Well, first of all, we have something called computer vision. So anything that has to do with images, like robots, for example, a robot that has to find where you are and give you you can give it some commands. Robots that, for example, do some gardening or do some kind of tasks and chores. Manufacturing, so you'd have a supply chain and there's some kind of camera and it looks at each passing item and see if there's any defect or not. object detection. If you have, for example, a camera at your home and it detects your cat or your dog coming going like for the food, and it knows it's time for the food, so it gives them some kind of food. Or you can detect some kind of other anomalous thing. For example, if it's a guard robot. And then finally, self-driving cars, which is like one of the most difficult things to do. It's real-time detection of everything, real-time analysis, and it has to take the decisions of what to do with a real car in real time, and it has to be really good at what it's doing. Otherwise, we could put a lot of people in danger. So computer vision is one of the industries where deep learning has flourished and really helps when compared to machine learning. There's also natural language processing, which in this case targets text. So in this case, we talk about text, actual text. There's real-time translation. For example, if you have used Google Translate, for example, or now we have some fancy kind of translation apps that use voice recognition. So it can understand what you are saying, and then it can translate it into another kind of language. And of course, chatbots, so virtual assistants, you can talk with them in natural language and they will understand, they will do the thing, but there's no one behind it, it's just some kind of AI, which in this case is deep learning AI. So in NLP is also good. We're actually gonna see an example of computer vision. We're gonna work a lot on computer vision today, and then we're gonna see one example of natural language processing in the end. Afterwards, that's recommendation system. So anything with recommendation, YouTube recommends you videos, Netflix recommends films, Amazon recommends products, whatever website where they recommend something to you, it's based on recommendation systems. And now it's based on deep recommendation systems, meaning using deep learning. This will not be included in this course, but there's another workshop that's focused on building recommendation system with Nvidia. And finally, reinforcement learning, which is one of the most difficult parts of deep learning. This is when you create an actual bot, an actual simulation, a robot or something. We call this an agent. And that agent has to be able to beat some kind of task. It could be a game, it could be an actual task. So an example would be AlphaGo from Google DeepMind, that actually have managed to beat the world champion in Go. There's actually a documentary that's free. You can watch it on YouTube and on Netflix. It's called AlphaGo, where they document everything. It's amazing. I feel like it's a film more than a documentary. So I do recommend you to watch it. It's called AlphaGo. And then, for example, you have seen any type of AI that like plays games like League of Legends, like FIFA, like whatever type of game online, offline, and they manage to beat the best video gamers in the world. That's called reinforcement learning. And not only on games, for example, stock trading is type of reinforcement learning. So basically anything that has actions to do, and depending on the action, there's kind of a feedback, a reward or not a reward. That's called reinforcement learning. So this is one of the most difficult ones. It demands a lot of data and specifically a lot of computation power. It's one of the more heavy ones, and we'll not be able to see that. All right, we're at the end of the slides. So overview of the course. So now we're going to go to our first hands-on exercises. You're going to get comfortable with the process of deep learning. We're going to get exposed to different models and data types and get a jump start to tackle your own projects, as said. Um, Basically, what we're going to see now is the first example, which is the hello world of deep learning. You are going to log on to the Jupyter lab, and you are going to check the first one, which is called 01 MNIST. And from there, you're gonna train your first deep learning model. You're gonna load your data. You're gonna pre-process the data, and you're gonna see how it works. So for now, since we did not go in depth how things work, you are not expected to understand everything. Just go with the flow. You will read it. I will keep you up to date with that. You will read that. You'll try to get a feeling. And then in the next presentation, we will explain what actually happened. So now we're just going to see the code and see that it's very easy to do code-wise. So to do that, as we have said, we're going to use a GPU-powered Jupyter Lab, which is, again, let me show you how to access it. Again, you just have to click on Launch the Course, and it will get you here. And this is the GPU cloud-powered server. So you have access to this. It's Linux. And we have on the left side all of these different IPNBs. So the first one is Jupyter Lab is just for the people that are for the first time using Jupyter Lab. So you have some instructions on what it is, how it works. Basically, just there's a left sidebar with all the data, the images, and the code. You have some terminal in the launch. You can open a Python 3 notebook. You can open a console. You can do a lot of stuff, but in our case, we don't need to do that for now. Um, and then basically there's a lot of text you can read, and then there's these things called cells. Basically it allows you to write Python code and allows you also to write Linux code, and then you can run these to execute either by clicking on this run button on the top. There we go. Or by doing shift enter, control enter, depending on what type of computer we have. So it does the same thing. There we go. In the end, so in this case it's just simple, so we don't need to complete this. You will see this in each IPMB. It says clear GPU memory. So since this is an actual computer, we have access to an actual server. You have limited RAM. You have access to some kind of, like, I don't know how much exactly, but you have RAM. It's limited. So each one of these, when it's open, it's gonna eat some of that. And we better close anything that you don't use yet. So you could just go on and execute that. Or I personally prefer to just close the tab. And then what I do is I go to the list, and you can see there's like these small green circles on the left of them. Let me just zoom in a bit. Yeah, so as you can see, there's like a small green circle. That means that the lab, that exercise, that lab at IPMB is currently working. So what you wanna do is do a right click and then shut down the kernel. And there we go. Now it's closed. Sometimes it works with the code, sometimes not. So I just personally do that. I just go here and do shutdown kernel, and with that we're good. So if at any time you are working and you get a kind of error that says there is no more memory, we cannot launch it, whatever that has whatever thing that has a relation with memory, it's most likely that you have these kernels open. So just go and shut them down. Okay, and yes, thank you for answering about the question about the Linux. Yes, you can use Linux commands here. You can either go to one of the cells, and as Jack has said, put your code. So let me just show you how. Yeah, you just add this symbol and do whatever you want to do. If you want to create some kind of directory, if you want to do a search of what you have, a grep, a wget, whatever, it's a good thing that you use this symbol. I do not know the name of the symbol, to be honest, but you have to use that. Sometimes you can work it. I don't know if it works with this. Yeah, it does not. It's not like Google Colab. So yeah, everything you want to do, just add the that symbol before, and yep, you have access to Linux, so you can use that. Okay, so I'm gonna shut this down. Exclamation mark, thank you, I forgot the name. Okay, and let's just go back here. For the software, so the cloud server that we have can actually work on any one of the deep learning platforms, TensorFlow, PyTorch, MXNet, etc. But for the purpose of this lab, we're going to use TensorFlow and Keras. And it's a good idea afterwards that you try the others, just to get an example of what people are using. There's no clear winner, which one of these are the best ones. There's some kind of consensus that if you want to work on, for example, industry and use and deploy to millions of users, TensorFlow is the best. If you work on research and need, for example, to be very detailed about each step of your model, then PyTorch is used. But it's just general consensus. All the time we see companies using PyTorch, we see researchers using TensorFlow. It's just the personal preference. Do whatever you want. All right, first exercise. No more talking. Let's get you working. We're gonna do a classification of handwritten digits. So for this, you are going to train a network to correctly classify handwritten digits, and you are going to try learning in your network by getting exposed to the example. So for this, let's go. I want you to go to the Jupyter lab, and I want you to open the 01mnist.ipmb. Okay? Open that. Let me just check. Zoom this. There we go. Let me just see the question. There's a lot of questions in the Q&A. Oh, perfect. Thank you, everyone. Thank you, the TA team, for answering all the questions. Okay, so do you all have the MNIST open? Perfect. Okay, then with that being said, you will have 20 minutes. So it's how much? It's 9:13. So let's take 20 minutes. You have 20 to 25 minutes to work on this. So you will have, like, we are not going to help you out with this. So it's actually hands-on exercise. You have to do it yourself. I'm just going to give you a brief overview of what's going to happen, and then it's up to you. So basically, in this case, the objectives is simple: to understand how deep learning can solve. You will learn about the MNIST handwritten digit dataset, which is one of the most popular datasets out there. You will see how to use the Keras API for the first time to load the data and prepare it for training, because you can't just throw in data and hope for the best. You're going to see how you can create your first simple neural network to perform the task. You're going to train it, and then you're going to observe the performance. So in this case, you have some text to explain the problem, the solution. Here we can see the actual data set. So you will give the model these pictures, and the model will have to discern what each picture is. Is it a 0, a 1, a 2, or 3? This may this may sound simple, but at the same time, there are some ones that look like sevens, if you can see this. The 0 can be said it's part of the 8 and part of the 9, like the 8 is technically two zeros. There are some numbers that are written in a weird way, so it's not that easy to do that, especially when you write it. So machine learning has to learn how to do that. So yeah, there's a lot of information. You will learn about what's called training and validation data sets. We're gonna learn what's X-train and what's the labels. But basically, the X's will be the inputs that you give the model, which in this case are the pixels of the picture, and the label will be the actual number. So is it 0, is it a 1, etc. You will learn how to load the data into memory. You will explore it and see all the different details about this data set. You will prepare it so that the model can actually access it, normalizing, doing some kind of encoding that allows you to turn text into numbers. And then you can create the actual model. And as you can see, it's like one line, two line, one line. That's not a lot of things to do. You can train the model in one line, you observe the accuracy, etc., etc. So all in all, there's like 20 lines of code, not a lot, but there's a lot of things you have to read. So I'm going to give you 20 minutes to work on this. Maybe they might sometimes ask you to do some tweaking to the code. That's part of the work. If you manage to finish in the 20 minutes, there's a bonus exercise in the end. I do recommend you to try it out, because that will be the base of the next presentation. If you don't, there's no problem. And in those 20 minutes, the TAs and I will be here to help you. We cannot give you the answers. That's up to you. You have to do it, but we can guide you. So if you have some kind of errors, we can help you out and say what you should do. If you have any questions, for example, you did not manage to understand some, like, for example, categorical encoding or whatever, you can ask us to explain, but you have to do it yourself. Everything clear? Perfect. Then go on. 20 minutes should be enough. I will be here with you, just waiting for the answers. I will put the dashboard for anyone not here. Just start. Go on. Let me see. Good luck. Tools. Whiteboard. Okay. Go to 0. Oops. Yeah, sorry, I didn't warn you about the poll. Let me just do it again. We're gonna start the poll right now, and you have to choose yes or no. So wait until I give you the question before answering. Wait, as I was saying, wait a bit. So it's basically yes or no. Did you finish the lab or not? Sure. You can just answer on the poll, people. You know, don't need to comment. That way, I can have a number. Okay. So I see that we have, I think, half of you, a little bit less, are still not there. Okay. So since there's a considerable number of people who did not finish, uh, let's just add 5 more minutes for you to finish. I'm seeing that you're all in the training phase, Nora. And for the rest, just try to work on the bonus exercises. Try to find the best combination of M and B. We'll be also talking about that in the next presentation. So try to get the best loss with the best combination of M and B. Let's see where you can get what you can get. Okay, so we are 9:42. Let me do another poll. So again, if you choose yes, it means you finished the lab, not the bonus exercise, but the lab, and no means no, you're still stuck. So there we go. Okay, so I see that a lot of people have finished the lab. In that case, perfect. We can go and finish that. In that case, let me just walk through what we have seen. So really, really quickly, let me walk through the lab now. I'm gonna go and present my screen. Desktop share. All right, there we go. So can you see my screen? Perfect. So let's go quickly about what you said. So as you've seen, first of all, it's easier. I think it's easier than you thought. Since no one like asked us a lot of questions, like you asked us a lot of questions. That's good, but there wasn't a lot of question about why we should do this and that, and this is not clear. So I guess that means that a lot of it was very clear. Very happy to see that. So basically, let's just quickly do a rundown. What we did here is simply we collected our data set, which is like the thousands of pictures, 70,000 grayscale images of these 0 to 9 numbers, digits. And so as you've seen here, we had two types of data. So it wasn't one big chunk of data. We had what's called training and validation data, and we had what's called inputs and labels. So these are some new things that you've learned. So basically, training and evaluation just means when we said earlier that you want to our model to take some guesses and then we have to evaluate the error. This is what we mean. We get a subset of the data for the model to start doing the guesses and training, etc., etc. And once it finished doing that, we test it on some data it has never seen before, which is called the validation, and that's where we actually get the error and see how well it's doing. And to be able to do that, we need some inputs and we need some outputs. In this case, the outputs are just the actual like values, and they are called labels. So from now on, we can say features and labels, inputs or outputs, uh, and there's a lot of other words like independent, dependent variables. But labels for now on will be the output, so the class that you want to classify or whatever. So we've seen that you had four variables: xtrain, which are the images used for training, ytrain, which are the labels for those same images, and then xvalid, which are the images for the validation, and again yvalid, which are the labels for them. So to get them, in this case, it was very simple. MNIST being something very simple and existing, it's already existing in the TensorFlow.keras dataset. So again, Keras and TensorFlow, they are the frameworks we are using, and they have made a merger. Now we have TensorFlow.keras. You might find some tutorials with only TensorFlow and only Keras. Those are the older version. Now we do from TensorFlow.keras to say the most up-to-date ones. There's a lot of data sets. For now, we just use the MNIST one, the most easy one. And in this case, we had the splitting of the data ready for us. So they did the splitting for us. In other problems, we will need to do splitting ourselves. So in the next project, the 02 ASL that we will see, we will do this ourselves. But for now, they made it easy for us. We just have that. We then went on and explored the MNIST dataset. So we used these functions, so these attributes dot shape, which gives us the shape, or we say the dimensions of each of our dataset. This means we have 60,000 images. Each image is 28 pixels by 28 pixels. Since each pixel is a value between 0 and 255, because we are working on grayscale, that means that we have 28 times 28 total values to work with. For the validation, you only have 10,000, and it's the same shape. And all of these, well, in this case, they are uint8, just a measure of type. Like this is a measure of optimization. That's why we don't really need to see that. Dot min, which is the minimum, you can see 0 is the minimum value, which means it's the color black. And the max is 255, which is the color white. And if we get our one example, so we said that the first dimension is like the number of the pictures, meaning that xtrain of 0 will give us the 28 by 28 pixels of the first image. So by doing that, we can see the array that we have. So it's it's made into arrays of 28 each time, 28 by 28. We can see a lot of zeros, which is the black part, and we have a lot of colors, which are the white part. And we can visualize this using matplotlib, which is used for doing all of these pictures. This is the same image. So this is the image representation of this. So there we go, color black, and then the different shades of white. So it's not only white, it's shades of white. Okay, so in this case, the question is this a 5 or a 3, etc.? We have our answer in the white train dot of 0, which is a 5, and this is how we're gonna evaluate our model. So now maybe the thing that you have like learned is how to prepare the data for training. So we have done three things. First is called the flattening. So for the flattening is basically we like neural networks and deep neural networks do not work with multiple dimensions. They only take one vector as an input. And so we have to reshape or change, let's say, the shape from a matrix of 28 by 28 into one big vector of 28 times 28, which in this case will become a vector of 784. So when you do xtrain.reshape and you give it this thing, this input, not this thing, it understands that for each one of these, we just want to merge the two other dimensions into one. And if this, for example, was not the right dimension, let's say 3, then it will give us oh yeah, sorry, I did not define the others. Well, it will give us an error because it has to be the right type. Yeah, sorry, I did not this. There we go. There we go. So we cannot reshape the sides. It has to be the right one. So 4, and this means that we can be sure that if there's no error, we are doing the right thing. So another check for the shape. Again, this time we have the same things, but it's one big array instead of multiple arrays. Okay, so now we have to do something called normalizing. Normalizing is just putting the values between a certain range. And this is used to make, for one, things faster, more precise, and specifically when you have multiple data, and for example, these ones are between 0 and 255, and another one would be between negative 1,000 and positive 2,000, well, they are not in the same scale. So with normalization, we can put everything in the same scale between 0 and 1 or minus 1 and 1. You choose it. And with that, it will make it faster and will make it more coherent and better for the model to train. Because the coefficient, they will not have to, they will not have to take into consideration a 0 to 255 scale and a minus 1,000 to 2,000 scale. They're all between 0 and 1, so the coefficient can do its job without any problems. So in this case, since all the values are between 0 and 255, we want to convert them into the values between 0 and 1. So we just divide by 255, which is the maximum, and you can get our normalized vectors. Finally, this is actually optional in this case, but they wanted you to get an idea of how things go. When you have text in your data, not only numbers, that's a problem because machine learning uses math, and math are numbers. You can't use text. So categorical encoding is a way to transform text into numbers. And for example, if you have red, green, blue, green, whatever as a actual color, what you can do is do something called a vector, a one-hot encoding, meaning that instead of one column with the different values, we create several columns for each different value, and you just give it a 0 or 1 depending on the actual value. So for example, you have red, green, and blue. We have, instead of using actual color, we will delete that and create 3 columns: is red, is blue, is green. Since in this one it's red, so we get true for is red, false for the rest. Since this one is green, we get true for green and false for the rest, etc., etc. Then we just need to convert the true or false to 0 and 1s, and bam, with this, now we go from text values to number values, and you can use this for our training machine learning process. In this case, well, we don't really need to do this, but it's a way for you to get accustomed to this kind of thing. What we did here is convert our labels, so from 0 to 1 to 9, into those vectors. So instead of having 0, 1, 2, 3, 4, we actually have arrays, and each array actually like defines a number. So we have nine of them, some 0 to 9, so there are 10. And for example, for the first one, it's a 5. So you remember y train of 0 was 5. So 0, 1, 2, 3, 4, and 5. Now we know it's the fifth one, it's the sixth one, so it's number 5. Again, here it's the number 0, 4, etc., etc. So that's a way to encode the labels. Now, since everything is numbers and already done, we can go and create the model. And as you have seen, it's very easy to do that in Keras. So we always have an input layer that will get the vector of 784 pixels. And that input layer will then transfuse it to other type of layers. So to start, we always do this. We always import sequential, and we initialize our model. So this is how we start. From there on, there are a lot of different layers you can use depending on the problem. The most important and not important, but let's say the most common one is dense layer, and you will see what dense layer is. But basically, it's a way it's a way to create a lot of neurons, the circles that you have seen earlier, and they get the input. So in this case, we are adding that dense layer. We are adding for that dense layer 512 units, so 512 circles, 512 neurons. Each one of them is actually a function. We're going to talk about activation function and what they are in the next presentation. And since this is the first layer, it's going to get the input. So we have to add this input shape in the parameters. Once that's done, we can add, for example, another hidden layer. So this is the input layer. And then we can create another hidden layer. So to make it a deep network, not just simple network. In this case, it doesn't matter what kind of unit and ReLU and activation we use. It's a simple example, so anything can work. So we just create another one with 512 units. And then an output layer. This time, since we have 10 digits from 0 to 9, we say we need 10 units, not 512 or whatever. So the output layer always has to have a number of units equal to the number of classes. If you are having a binary classifier, yes or no, then you only need one unit. You can take the value of it which will be between 0 and 1, and say if it's closer to 0, it's 0. If it's closer to 1, then it's 1. But you have multiple classes. In that case, you put a number of units equal to the number of classes you have. In that case, we have to use this activation function. And again, we are going to see what it is in the next presentation. Finally, to get an idea of what we have done, we have this possibility, which is model.summary. And this gives us a summary, as the name says, of what we have. So we have 3 layers. We have 512, 512, and 10 of a how is it called, neurons, and the number of parameters. So the number of parameters here is big, as you can see. And that's because what it does in a dense layer, all neurons connect to all following neurons or past neurons. So in this case, we have 512 neurons. Each one of them will get multiplied by the 784 inputs we have seen from the pictures. And so when you multiply both of that, you get this number. And then the 5 and 512 neurons, they will connect to all 512 neurons in the next layer. And so this is the multiplication of them. And finally, 512 times 10, they will have the multiplication. Plus there's like 10 more. And there's like 512 more here and 512 more here. That's called a bias. That's the B if you did the bonus exercise. So each neuron is a function. So it's a mx plus b. So we have that, the m, and we have the b. We're going to see this again in the bonus. So basically we have, for just such a small model, we have 669,000 parameters to train, which is actually very, very, it's a giant model for such a small network. So now that we know this, we can go and compile our model. So compiling just means, hey, we finished defining the model. We are still going to give you some more information on what to do. We can add some more, and that's it. Close it, freeze everything. We're good to go. Let's work with that. So that's what compile does. Just says once this has been executed, freeze the model. We know what you're going to do. Now it's time for the training. Finally, training is done in one line. All you have to do is model which is the model you have created, dot fit, which means that it will try to fit the data. So those thousands of neurons will try to guess for each X train and the Y train, for each X train, sorry, a prediction, and it will compare that to the Y train. We will do that 5 times over all the data set, and then we will compare with the validation data set. So in this case, we will use the X train and Y train to see how well the model is learning from the data, and then we're going to compare with data it has never seen before to be sure that the model is learning the right things and not just memorizing this. If we have a perfect score on X train and Y train, but you have a bad score on X valid and Y valid, that means that the model is not learning to classify digits. No, it's just learning to answer the question for this type of data. But we want to use our model in other future cases. So I want it to be a general model and like have decent results on both the train and the valid. So here you can see for each epoch, and epoch again just means that you have passed all the data once. So in each epoch, we are seeing a loss, an accuracy, a val loss, and an val accuracy. So the loss is how much of an error is there, and the accuracy is how good are we at doing our stuff. And this is for the train, and then this is for the validation. Again, if the loss is perfect or the accuracy is very good, but the val loss and the val accuracy are bad, it's not. It means that it's only good at the train and not a general good model. So I want them to be very relative to each other. So in this case, in the final epoch, we have 0.00667 for the training loss and 0.12 for the val loss. So the val loss is higher than the train loss, which is bad. But let's just try and see the rest. Accuracy is 986 for train, and val is 979 for validation. Meaning that all in all, the model is still better at the X-train than the validation, but since these values are very close to each other, it's a good model. If this was, for example, 986 and this was, for example, 0.7, then it's a bad model because it's only good for the train. But since these are very close to each other, it means that our model is good at what it does. Um, so yeah, so that's how you fit a model. And finally, yeah, we observe the accuracy, so we just did just that, and we are sure that it's a good model. So basically, this is a process of how we can do machine learning. As you see, it's like 20 lines of code at most. We did not give it any kind of rule. We didn't say, for example, if there's kind of a line of pixels, that means a 1. If it's a circular function, then it's a 0. We didn't say anything. We just give them the data, the labels, and it did all like everything on its own. And it's based on math and how it works, etc. We're going to see in the next presentation. But it's basically based on the same thing as the bonus exercise. In the bonus exercise, you were given x's and y's, and they were plotted, as you can see. You were given some starting values, so -2 and 40. And each time you can see the model that you have created, which is -2 times x plus 40, like define this line. But this line is very different from what this from the points, that the trend line of the points. We can see that the points are going upwards to the right. Well, this one is not doing that. So when you calculate the loss, it's a very big loss. We have to get this near to 0. So what you would do in this case, you would randomly try some different result. For example, from -2 to 0, you get it's up. It's better loss, but it's still like very big. Maybe you get this down to 20. Yeah, not bad. Maybe not 1, but maybe not 0, but maybe 1. Yeah, this bit better. You can play around with this and try to get like the best combination. You can go, for example, and go even further, like 4.0001 or to 19 point whatever, let's say 13.4, whatever it is. Maybe it's good, maybe not. But then the important part is that you are, in this case, trying, like changing the coefficients, observing the result, and you're trying to go the way where it's getting a better result. So the machine learning model is doing the same thing, but in a mathematical way, not in a visual way like we are doing right now. And how it's doing that, we are going to see right now in the next presentation. So I'm going to open up the next presentation. And before we start into it, because this presentation is also very heavy and there's a lot of math, I want to ask you if you want to take a 10-minute break to refresh, or if you want us to like go right into it. This will take us like 30 to 45 more minutes. So do you want a break or a no break? Let me just create a poll. You choose in the poll. Yeah, in the poll, please, in the poll. Break just means a pause. We're gonna take a pause. So are you for or against? Let's say 5 to 10 minutes of a break. So a lot of you are saying 5 minutes. So yeah, 5 minutes would be also good. Okay, so I'm seeing the results, present and end. We have a lot of people that want a break. So let's take a very quick, not too much. Let's take it's 10:04. Let's take 6 minutes of break and then we can finish the second presentation. In the meantime, I'm here to answer any questions. So if you have anything, please shoot in the chat.